During a total solar eclipse, the moon moves between the Earth and the sun. When this happens, the disk of the moon appears to perfectly cover the disk of the sun, even though the sun is much larger than the moon. But how is this possible? The sun is 400 times bigger than the moon, but by sheer coincidence, the moon is 390 times closer to Earth. Size and distance cancel each other out so that the moon and sun appear to be almost exactly the same size.
It all has to do with the moon's orbit around Earth. As the moon circles our planet, it passes between Earth and the sun about once a month, but it usually misses a perfect alignment because the moon's orbit is slightly tilted with respect to the plane of Earth's orbit around the sun. Most of the time, the new moon passes either above or below the sun. Observers not located on the path of the moon's shadow will see only a partial eclipse in which the moon's silhouette doesn't completely block the sun from view. In some cases, the center of the moon's shadow misses Earth entirely, and no one gets to see totality or the annulus, although a partial eclipse can still be observed. As with all solar observing, you must take proper precautions to protect your eyesight. Looking at the bright sun without any protection will cause permanent eye damage, and a safe solar filter cannot be made from common household materials. Proper filters are specifically designed for observing the sun. The best options include mylarized or thin polymer eclipse viewing glasses, but make sure that they're in good condition with no wrinkles or pinholes. The safest way to observe the eclipse is to project its image through either a telescope or a pair of binoculars focused to produce a sharp image. Remember, do not let anyone look through the device at the sun while you're doing this. You can also use a small flat mirror to reflect a low-resolution image of the sun onto a shaded surface, such as the side of a building. The farther away the building is, the larger the sun's image will be. Pinhole projectors work well for deep partial eclipses. Poke a round pinhole through a piece of stiff paper or cardstock and let the sun's light shine through it onto a shaded surface, and you'll see a tiny image of the sun. If you're projecting about 3 feet, the image of the sun will be about a ½ inch in diameter. And again, the greater the projection distance, the larger the image.